Hello class, today what we are going to look at is how to prove triangles are congruent. Now in the previous video we saw that in order to prove any two polygons congruent you had to show that all of the corresponding sides were congruent, you had to show that all of the corresponding angles were congruent. So if you had a triangle, that means you had to prove 3 sets of sides congruent and 3 sets of angles congruent, which is 6 different things we had to show congruent. But triangles are actually special. Triangles, we don't have to have all 6 sets of parts. All right? What we really only need are 3 sets of corresponding parts in order to prove 2 triangles congruent. So maybe you have all 3 sides, or all 3 angles, or all 2 angles and a side, or 2 sides and an angle. There's some combination thereof. Now, the thing is, only certain combinations will work. Most combinations work, but some combinations will not. All right, and so that's what we're going to look at here. All right, now the first one. What do you have if you have all 3 sets of sides congruent? So if all 3 sets of sides are congruent, well, that one's pretty obvious. Yes, this will prove the triangle is congruent. All right, this is called the side-side-side congruence theorem, or just SSS congruence theorem. You can abbreviate this. SSS for side-side-side. All right. Next, what if you have a side, an angle, a side, an angle, and a side? All right, let's take a look. So we have 2 sides, and we have the angle in between the sides. This will also prove triangles congruence. This works. All right. Because for that to work, there's only one other length of sides there, and so everything's good. Now, notice this is side, angle, side. The angle has to be in between the 2 sides. All right. So SAS congruence theorem only works if the angle is in between the 2 sides. All right. So that SAS, the angle is in between the 2 sides. What if we have it the other way around? What if we have 2 angles and a side in between those 2 angles? So angle, side, angle, angle, side, angle. We have 2 angles and the side that is included in those 2 angles. And yes, this will also prove congruence. All right. So this is angle, side, angle congruence theorem, or ASA congruence, right? Because the side is in between the 2 angles. All right. What if the angle is the side is not in between the 2 angles? What if we have an angle, and then a side that's not in between them, like this? We have an angle, and then this side is out there. All right, so it's not in between the 2 angles. This is also going to prove congruence. This is the angle side congruence theorem, AAS, and this works. This will work. Angle, side. Notice the side is not in between the angles, and so the S is not in between the 2 A's. All right. Okay. What if we don't have any sides at all? Let me just. All right. What if all we have are the 3 angles? Angle, angle, angle. What does that do? Well, angles are congruent, but the triangles are not, are they? This will not prove congruence. Okay, the triangles will not be congruent. Well, they could, but they're not guaranteed to be congruent, so you can't prove it. Okay, they might be similar, but they are not going to be congruent necessarily. All right, this will not prove congruence because, as you see, I have 2 angles. All of these angles are congruent to their corresponding angle, but the triangles are different sizes. They are the same shape, but they are different sizes. All right, what if we have 2 sides in an angle, but the angle is not in between the 2 sides? We had side, angle, side. Let's take a look at side, side, angle. All right, let's open that up. And no. So here I have 2 sides congruent to those 2 sides. The angle is congruent, but the triangles are not congruent. So that does not work. All right. So even though we have 2 sides and an angle, since the angle is not in between those 2 sides, you cannot prove congruence for these 2 triangles. Doesn't work. And I skipped one. Oh no, hypotenuse-leg. Okay, so this has a hypotenuse, so obviously this is for right triangles only. Okay, so let's take a look at this. We have the hypotenuse is congruent, and we have one leg congruent, and these triangles are congruent. Okay, This is kind of like that side angle we had just a minute ago, right? We've got two sides and an angle that's not in between the two sides, so I thought we said that didn't work. Well, it doesn't unless it's a right triangle, okay? That's the only way that this will work, is if this is a right triangle, all right? So hypotenuse-leg congruence works, side-side angle does not, all right? So these are the 5 congruence theorems that will work. All right. You have to have your angles and your sides in this order. Either all 3 sides congruent, 2 sides and the angle that is in between those 2 sides, 2 angles and the side in between those 2 angles, 2 angles and a side that's not in between the 2 angles, that's fine. So basically, as long as you have at least 2 angles and a side, these 2 here, you're good. But if you only have 1 angle, then it depends on where it is. If you've only got 1 angle, that angle had better be in between the 2 sides that you know are already congruent, okay? Unless it's a right angle, in which case, if you have the hypotenuse and one of the legs congruent, then it works. But for the most part, you need either all 3 sides, 2 angles and a side. Just pay attention to where your side is, was what you name it, but it'll still work. 2 sides and an angle if and only if that angle is in between the 2 sides, or if you have a right triangle, then you just need a hypotenuse and one of the 2 legs congruent. All right? So those are the 5 triangle congruence theorems. I hope you found that useful, and I'll see you next time.